Okay, next video. Solve the system of equations, same directions. In this case, this one appears to be a bit different because there's decimals. Alright, we've learned in the past that we've solved equations with fractions, and what we did was we got rid of those fractions by multiplying everything by the least common denominator. In this example, we'll do something similar, only we'll multiply everything by 10 to get rid of our decimals. Okay, so why 10? Well, you might remember if you multiply 0.1 by 10, it becomes 1, right? 1/10 times 10 is just 1. Or when you multiply by 10 or powers of 10, what it does, it just ends up moving the decimals. Let me show you over here on the right. For example, let's say I had 0.7 times 10. That's 7. Right? It just moves that decimal over 1. What if it was 0.07? And if you multiply that by 100, that would also be 7, right? Multiplying by powers of 10 just moves your decimal place as many zeros as there are. So 0.07 or 7/100ths times 100 is 7. Okay? And these are the kind of numbers we like to work with, these integers. They're a little bit easier to deal with. So I'm able to do that over here. If you look at your problem, it says 0.1x plus 0.5y equals 1.1. Now we've talked about a couple methods to solve these. So this is really going to be one extra step. It's not really specific to solving systems of equations. It's just getting rid of decimal places, which we could do at any point if we had decimals in an equation. Okay? So I see that these are just all one decimal place. If I multiply by 10, it should clear the problem of decimals. Alright, so let's try that. Multiply everything by 10, and that's just going to be my first step, so I don't have decimals anymore. Alright, so it's both sides by 10. So I'm going to rewrite what I get. Distribute this 10. 10 times 1/10 times x, or 10 times 0.1x is 1x. Okay, or x. 10 times 0.5y is 5y. And 1.1 times 10 is 11. Okay, and now I don't have decimals anymore. I'm going to rewrite my second equation. And take it from there. Okay, so at this point then we're right back where we were before. We have to decide how to solve this. I can solve by elimination or substitution. Typically we solve this by elimination because I can see I have x and y on the same side of the equation for both equations, right? Over here for the top equation, 4x plus 5y, I got x and y on the same side, same here. So we did elimination. So in this case you'd have your choice. I can try and eliminate x. I need this to be negative 4x, right? Be the easiest thing to do. Or I can eliminate y. I need this to be negative 5y. Either of those would work fine. I'll pick the first option and go to eliminate my x term. So I realize if I multiply by negative 4, I'll have negative 4x and positive 4x. Okay, so I'm going to multiply both sides by negative 4. Okay, so the top equation becomes negative 4x minus 20y equal negative 44. And the second equation I still haven't changed. It's still 4x minus y. Equals 23. Okay, so now I add them together. I add these two guys together, and these go away, right? Elimination. We've eliminated x. Negative 20y and negative 1y is negative 21y. And if I add negative 44 to 23, I end up with 21. And that should be negative 21. Okay? And finally, I'm going to divide by negative 21 to get my solution for x. I'm sorry, that is my solution for y, I should say. Divide both sides by negative 21, and that gets y all by itself. And negative 21 divided by itself, of course, is 1. Alright, so I know that y is 1, so I'm going to come up here and solve for x. I'll pick the second equation. 4x minus y, which is 1, equals 23. Okay, you've done enough of these now. Hopefully it's getting a little bit easier for you. Add 1 to both sides. We've done a lot of these solving linear equations. You get 4x equals 24. And I'm going to divide both sides by 4. That's a 2. Divide both sides by 4 to get my answer for x. And that should be 6. Okay, so 1, 6, and I'm done. 6. Okay, so what's different in this video? The only thing that's different is that there's decimals given. Okay, so we can handle decimals, right? We just get rid of them. Multiply by a power of 10. The lowest power as possible. In this case, you notice you only had to move it one spot, so you multiply by 10. If there were 2 decimal places, if you had a number like this, right, then you might have to multiply by a higher power of 10, then maybe by 100 if you need 2 spots. Okay? Alright, one more topic. One more example. Okay, so same thing. Solve the system of linear equations. Okay, I'm going to show you another case where this one's a little bit different, and we'll see why. But I don't know it's different yet. Okay, I'm just going to follow the same process that we've always followed. I got 12x minus 3x equals. Oh, that should be a y. Let me correct that. I'm just going to draw this in here. I'll try that one more time. 12x minus 3y. Okay, that's not too bad. Alright, 12x minus 3y equals 90, 4x minus y equals 30. Alright, so same thing, this is set up for elimination. X and y on both sides, so I look at that and I say, okay, I'm going to eliminate either x or y. If I multiply this, let's eliminate x. Our goal is to eliminate x. So I want this 4x to become negative 12x, right? So multiply this bottom equation by negative 3. And that'll give me the opposites that I'm looking for. Alright, so let's see what happens. Rewrite the first equation, 12x minus 3y equals 90. And the second equation, negative 12x plus 3y equals negative 90. Okay, so far I've followed the same process. Now I add everything together. But look what happens in this case. That guy goes away, that guy goes away, and that guy goes away. Right? In other words, you add everything together and you get 0. Say it goes away, it means it equals 0. So I end up with a statement like this. Okay, I get 0 equals 0. So what does that tell me? They go back up to my original equation. Anytime you get a statement like this, we have a number equals a number, right? For these types of problems, that means that these are the same line. Okay, in fact, they look different, but they're in fact the same line. If I were to multiply by this instead of negative 3 by 3, think about what you would get. You would get 12x minus 3y equals 9. You get the same thing. So in other words, this is just a scalar multiple. This top equation is the scalar multiple of this one. So they're in fact the same equation. Okay, if you were to graph this line and this line would lay right on top of it. Okay, so these are in fact, there's a number of ways I can answer this. For us, if we end up with something like this, I'm just going to say something like this. Same line. Okay? Alright, I got one more example to show you on this video. I'll just draw a line right down here. So let me go ahead and write it. X minus y equals 5. Okay. And this one says 2x minus 2y equals 13. Okay, last example for this video. Alright, x minus y equals 5, 2x minus 2y equals 13. So again, this one is elimination. If I multiply this by negative 2, I'll have my negative 2x, right? I'll be able to eliminate x. The same process starts. These examples are a little different, but we always do the same thing to start. We try to eliminate. Okay, so rewrite my top equation after I multiply. So that gives me negative 2x plus 2y equals negative 10. okay, that's when I distribute this. Negative 2x plus 2y equals negative 10. And then the second equation I didn't do anything to. 2x minus 2y equals 13. Okay, so you'll notice I'm able to eliminate x here because negative 2x and 2x is 0. That's what I'm looking for when I add these together. That's gone. But in this case, this one goes away too, right? So if I add these left-hand sides together, I get 0. And then over here, if I add these two guys together, I get 3. So I get this weird statement, 0 equals 3. That's a 0. 0 equals 3, which we know is not true. Okay, 0 equals 3, we know that's not true. So what's that indicating for us? That's telling us that this has no solution. Okay, what that in fact means is those two lines, if I were to graph them, they would never meet. Right? In most of our examples before, we had two lines and we got a point, right, in x comma y, and that was where if we were to graph these, where the lines would intersect. In this example, they don't intersect at all. That means there's no solution. Okay, so you saw two kind of different examples here. Right here, same line. When you ended up with a statement like this, these were in fact the same exact line. One was just multiplied by 3. And these two lines are similar. They're actually parallel. If you were to graph them, they would run parallel and they would never intersect. That means they have no solution. Okay, so another way to write that would be to draw the empty set. I think your textbook uses this notation. Okay, that means the same thing. That means there's no solutions. Okay? Alright, do some examples, practice, and do some more practice.